Hi, my name is Philip. Today I will talk to you about a new algorithm for high utility quantitative item set mining. So let's start. Okay, so let me give you some introduction. I think you know about high utility item set mining. It is a data mining task. We want to analyze the shopping data to find what makes the most money. So here, for example, I have a transaction database. It contains some transactions that say what people have bought in a store. So for example, transaction 1 say 1 apple, 1 cake, for example. Transaction 2 means 1 egg. Some people buy 1 egg and so on. And then we have a profit table, like 1 apple is a $5, 1 bread $2, 1 cake $1, and so on. And the goal, what we want to do, is to find what the people buy and make a lot of money that has a high utility. So here, for example, we have a parameter we call the minimum utility. The minimum amount of money is $30. And the goal of high utility item set mining is to find all these sets of items that make at least that minimum amount, at least $30. We call this a high utility item set. So this is the solution. We find BD make $30, BE make $31, and so on. So there have been many papers about this topic, many algorithms. Okay, I will not explain this today. But there are some limitations about this. It is that even you find that cake and bread make a lot of money, we don't have the information about the quantities. So there is a new problem in recent years called high utility quantitative item set mining. So we don't only want to find something like coffee and cookie and eggs make a lot of money, but we want to know about the quantities, like 3 boxes of coffee plus 2 boxes of cookies and 6 boxes of eggs make a lot of money. So like high utility item set mining, but with quantities. So to do this, there have been a few papers, as you can see here, and they use different approach to find the solution. Okay. In previous work recently, last year, we proposed one algorithm, CHUQI-Miner. It is very fast, up to 20 times faster than the best algorithm until now. But there is one problem about this. Still, even with this algorithm, we can find the item set make a lot of money, the products. But sometimes these item sets are weakly correlated. For example, we find that 10 pens and 1 diamond make a lot of money, $500. But maybe there's not a strong correlation. Maybe pen and diamond, the people buy it together just because almost everyone buy the pen. Okay, so it's not really because there's a relationship. So in this paper, what we want to do, we want to combine the concept of high utility item set with quantities with that of correlation to find the item sets, the items that are correlated and also make a lot of money. Okay. So our goal is to find the correlated high utility quantitative item sets. So to do this, we design a new algorithm we call the CHUQI-Miner. So here I will skip the details, but the main idea is we look for a single item, make a lot of money, then we try to combine them recursively until we find all the patterns. So one thing is interesting to say. We can find the item set with the range for the quantities, like B 2 to 4 bread, okay, with 5 apple. So we can have some intervals like this also for the quantities. So I will skip the details about this, but mostly to evaluate the correlation of the items, we use a measure called the bound. The bound of an item set X means how many times the items of X appear together divided by how many times at least one item appears. So again, we don't have a lot of time. I will skip the details about this. So we define a new algorithm called CHUQI-Miner for this task to find the correlated high-utility quantitative item set. So if you are interested by the details, you can read the paper to know all about the details about this. So we did some experimental evaluation to evaluate the performance of our new algorithm, CHUQI-Miner. We compared with the previous best algorithm, FHUQI-Miner, on different databases. So what we find here, we use the experiment on 4 databases, and here we change the parameter, the minimum utility, and we look at the time. And we find that here we have on top the previous best algorithm and then our algorithm. And our algorithm can be more than 30, 40 or almost more than 100 times faster, because we don't look at the weakly correlated item set. So we can save a lot of time. Okay. Also, we look at the number of patterns, and compared to all the patterns, we find only a few. So that means a lot of patterns are not strongly correlated. So not only our algorithm is faster, but it will find less pattern to find only the strongly correlated item set. So in conclusion, we presented a new algorithm called CHUQI-Miner to find the correlated high-utility quantitative item set, a new topic. To use the correlation, to find the correlated item set, we use the bound measure. So there is many possibility to extend this in future work. So that is all for my talk. If you want the code and data set, you can look at our software called SPMF. Thank you.